This is a video of the 6th grade math notes on Amplify Unit 1, Part A, Section 6.1. What are perpendicular lines? Perpendicular lines are lines that intersect and form a right angle, and a right angle is 90 degrees. Feel free to highlight or underline the important information that's also underlined as well here. The symbol for perpendicular lines looks like an upside down capital T. So if you look at this example, here's line 1 and line 2. When they intersect, when they meet, you can see the right angle, the 90-degree angle, which means line 1 and line 2 are perpendicular to each other. Note, the height is always perpendicular to the base. So if you look in all of the examples, I highlighted the height in pink and the base in blue. And if you notice that the base is always a side on the polygon and the height is just perpendicular to the base. So once you identify the base first, then I would go from there, and as long as it forms a perpendicular line and it reaches, let's say, the top of the polygon, that's the base. If you look at this last polygon, the base is on the right. We talked about this where the height can be horizontal, which is across. So the base in the last one is 6 and the height is 7. And all you have to remember is that the height and base must be perpendicular to each other. Now let's move on. Special quadrilaterals that you need to know. Quad means 4, lateral means side. Here are some quadrilaterals. You know that they are 4-sided polygons. Now, don't forget the word parallelogram. A parallelogram is a quadrilateral, so that means all parallelograms must have 4 sides. Parallelograms are quadrilaterals with 2 pairs of parallel sides. The opposite sides must be parallel. So if you look, now, example, square, rectangle, rhombus. These are examples of parallelograms. In the definition of a kite, it says 2 pairs of adjacent sides are equal. That means next to. So just so you're familiar with the word adjacent. Label the height H and the base B in the polygons below. So this, in the first image, the one on the bottom is the base, and the height is perpendicular to the base. If you look at the top right, the base could be the top or the bottom, and the height is perpendicular to it. If you look at the last triangle on the bottom, the base is on the bottom, and the height again is perpendicular to the base. Now, let's take a look at number 3, finding the area of a combined figure. What is a combined figure? So if you notice at the examples, a combined figure is made up of different polygons that have been combined. So what you need to do to find the area, you can decompose. Decompose means to break it up. We're going to break the figure up into polygons that you know the area of. Then find the area of each polygon and add the areas up. So if I look at example A, that's actually a trapezoid. It's a quadrilateral with only 1 pair of parallel sides. So if you notice, what I did is I cut off the triangle on the left, and I moved this triangle to the right, and I filled this in because the base both had 1 and the height is 2. So I'm able to cut off this triangle and move it over to the right. And this forms that yellow rectangle that I was able to shade in here. The base is on the bottom, the height is to the right. So if I look to count the base, I would count 1, 2, 3, 4. So the base is 4, the height is 2. To find the area of a rectangle, you just do base times height. 4 times 2 is 8. So the area for this example A is 8 square units. Now let's look at B, example B. I cut this up into 3 rectangles. Now the rectangle on top has a base of 5 and a height of 3. So 5 times 3 is 15. The middle rectangle I counted. Again, you're not counting the squares, you're counting the side lengths. So look, 1, 2, 3, 4, 5, 6, 7. The base is 7 and the height is 3. 7 times 3 is 21. So the area of the middle one is 21. If you look at the last one, it has a base of 4 and a height of 3. 4 times 3 is 12. Now, once I have the areas of all 3, I can just add them up. 15 plus 21 plus 12. 5 plus 1 is 6. 6 plus 2 is 8. 2 plus 2 is 4. So 48 square units is the area for example B. Now, if I look at example C, what I did is I cut this triangle off and I moved it over here and I filled it in. So it created a square there. And then if you look at the bottom, I also cut that triangle off and I moved it over here to create a new triangle. I mean a new square. So then this has an area of 4, this has an area of 4, and this has an area of 4. So you can add them up or just do 4 times 3, you get 12. So example C has an area of 12 square units. Example D, if there's a missing area inside the shape, you can subtract that area from the larger area. So, if I were to pretend that this whole thing is filled in, I count the side lengths 1, 2, 3, 4, 5, 6. The base is 6. The height 1, 2, 3, 4, 5. The height is 5. 6 times 5 is 30 minus the 2 that are missing. The area of this combined figure is 28 square units. Now what I would like you to do is put a little smiley face inside this, so when I come around and check, I could see the little smiley face that you put there. So inside where the 2 missing squares are. Alright, let's take a look at what area means. Area represents the total space taken up by a flat 2D surface. In class we mentioned that you could find volume, which is the amount of space inside a 3D like the classroom. Area is how much space is taken up on a 2D surface. So, area is measured in square units. The area of this example here would be, we would do 3 times 3 to get the area of the blue, which is 9. So the area of this is 9 square units. If you look at this green rectangle, the base is 4, the height is 3. 4 times 3 is 12, so the area of the green is 12 square units. Now, how to find the area of a parallelogram? So what I would do is identify the base and the height, and I counted. This is 2 units, the height is 4 units. I wrote the formula A equals BH. Base times height is 2 times 4, so the area is 8 square units. And the one on the right, this one's a little harder, but it's not too hard. The base is on the bottom, which is 2. The height has to be perpendicular to the base, which is 4. 2 times 4 is 8. So actually, the 2 figures have the same area. Now, they may not look like they have the same area, but they do. B, how to find, now at this point, we are now going to move on to area of a triangle. Now, if we did not cover this in class yet, at this point you could stop and you could go to the last page and do some practice problems in iExcel. Now, if we did cover area of a triangle, you could continue. I want you to notice the parallelograms down here. The parallelograms all have a base of 6 and a height of 4. If you look at this triangle, it has a base of 6 and a height of 4. What this tells me is that a triangle, and if you notice, like, look at the parallelogram down here, the rectangle, it has an area of 24, but this triangle is only half of the parallelogram. So a triangle is half of a parallelogram that has the same base and height. Now this only pertains when the base and height are the same. So if this parallelogram is 24, half of it would be 12. That means the area of this triangle is 12. You can do 6 times 4 is 24, but that's as if the whole rectangle is there, and it's not. Half of it, so you take base times height divided by 2, or half base times height. That's how you find area of a triangle. Now, what are polygons? A polygon is a closed plane, a closed shape with straight sides and angles. So to be a polygon, you need to have straight lines. If you look, all of these have straight lines. It has to be a closed figure, so there can't be any opening gaps. You should see angles. There should be more than 2 sides, especially if it's a closed figure. It has to be closed. And you cannot have any curves. So examples of polygons are here. And if you notice, non-examples are here. And again, if it's an open figure, then that's a non-example also. So these are polygons. Let's name the different types of polygons. A 3-sided polygon is called a triangle. 4-sided, we already know, is a quadrilateral. 5-sided polygon is a pentagon. 6-sided polygon is a hexagon. 7-sided polygon is a heptagon. 8, like an octopus, has 8 tentacles. An 8-sided polygon is octagon. 9-sided is nonagon, and 10-sided is decagon. And if you know, 10 years represents a decade. So a 10-sided polygon is a decagon. Feel free to pause and go back and re-listen to any section that you need. Now at this time, you can move on to Clever, go to iExcel, and practice any of these sections. Now again, if there are sections in here that we did not cover yet, you can just continue. You can just work up into the sections that we have. And don't forget to look over what we worked on in Amplify, Schoology, and worksheets in your binder.